All right, another one of the skills I want to review before we start the course is factoring. Now, if you studied factoring in high school, you probably remember that it's something that you spend an awful lot of time doing. So we can't go over all of the factoring that is possible. What my goal is to just go over a couple of specific types so that when it comes to practicing one of the first topics in calculus, which is finding limits, you will have some factoring skills that are fresh in your mind. Okay, so let's take a look at factoring a special type of a function, a difference of squares. And notice that we have here a difference. And we have two values that are both squares. Okay, and so when you square root each of those, if you square root a squared, the square root of a squared, that's a. And the square root of b squared, that is b. So you get the square roots in your factoring. And notice what we have here. We have this pattern that we have the square root of the first value, which is a, added to the square root of the second. So we have sum. And in the second bracket, we have the square root of the first value, subtract the square root of the second value, so we have a difference. And that's a pattern that works every single time. So using this pattern just means recognizing where you see a difference of squares. Now I've got one here. It's not very hidden. This is the square of x. All right, so it's x squared. And this is also 3 squared. So right away, we can see what our a and b values are for this. In this case, a is equal to x, b is equal to 3. So to factor x squared minus 9, that is equal to x plus 3x minus 3. And if you wanted to verify that, you could use the FOIL method and multiply those two binomials back together, and you'll see that you'll turn out with x squared minus 9. All right, so I'm going to write another one. Factor x squared minus 100. Pause the video, give that one a try. So x squared is the square of x, and 100 is the square of 10. So this is actually x plus 10, x minus 10. Now sometimes they are not quite so obvious as a difference of squares, but let's take a look at that, one that's a little less obvious. Okay, so what about 2x squared subtract 18? Now, 2 isn't the square of anything. X squared is the square of x. So that's partially got a square in it. 18 is not the square of anything. So one of the key things to remember always is, if possible, common factor. Okay, so common factor first. The common factor in this case is 2. And when we common factor out the 2, we're left with x squared minus 9. So this is a difference of squares. All multiplied by 2. So that will look like this. X plus 3, x minus 3. There. So sometimes when you remove a common factor, you will then see the difference of squares. How about when you don't see a difference of squares? What about x squared plus, or subtract, it's got to be a difference, 5. 5 is not the square of anything. X squared is the square of x, but 5 is not the square of anything. But what we were doing, let's go back here. We had a 9. The square root of 9 is 3 and 3. So we can use the square root of 5. So this will be x plus the square root of 5, x minus the square root of 5. And you'll see if you multiply those back together that you get x squared minus 5. Let's just do that off to the side. We will say x plus root 5, x minus root 5. X times x is x squared. X times minus root 5 is minus x root 5. And x root 5 times x is plus x root 5. And then plus root 5 times minus root 5 will be minus root 5 times root 5. Just writing that in for an extra line. Now notice, minus x root 5 plus x root 5, they wipe each other out. And minus root 5 times root 5, well, that's root 5 squared. Root 5 all squared is equal to 5. Okay? All right, so that's it for a difference of squares. Be on the lookout for them. They are, once you see the pattern, they will become more and more easy to factor. Okay, so the other special type we're going to look at is a sum of cubes. And right here we have a sum. And these two values are cubes of something. A cubed is the cube of A, B cubed is the cube of B, and these will factor in this pattern. So the cube root of the first term plus the cube root of the second term, the square of the cube root of the first term, subtract cube root of the first term times cube root of the second term, plus the square of the cube root of the second term. All right, very wordy, but let's take a look at an example with some numbers in it. So I have a sum of two values that are perfect cubes. This is the cube of x, all right, so that is x all cubed, and this is 2 all cubed. So now you can see that I have values for a and b. So in this case, a equals x, b equals 2. So let's factor it. It will factor to x plus 2. And now this is the trickier part. We want to put in a squared. A is x, so it needs to be squared. That is x squared. And then we want to subtract, watch the signs in this one, a times b, that'd be x times 2, 2x, plus b squared. B is 2, and when you square it, that's 4. Let me give you another one for you to try. I'll keep the sum of cubes formula right there so you can see it. So let's do x cubed plus 125. Pause the video, give it a try. Okay, so here a is equal to x, b is equal to the cube root of 125. If you're wondering, you can grab your calculator and do the cube root of 125, that is 5. And so now we have our a and our b value, so that will be x plus 5, x squared minus 5x plus 25. And again, the same thing can happen with these. You might have a common factor first. So let's throw in the common factor example and do 3x cubed plus 24. All right. It might have a look like it could be a sum of cubes, but not right away a cube. It's got a cube in it, but not a cube itself, right? So let's try common factor. Okay. Common factor in each of these two terms is 3. And when you common factor 3, you get x cubed plus 8.
Okay, I found this on the web.
Siri thinks I'm talking to her. And now we've already seen what that answer will be. So that's 3. We will get x plus 2, x squared minus 2x plus 4. All right, that is a sum of cubes. Now we will look at one more type. Okay, so the difference of cubes, and we have here a difference of two values that are cubes. And I have a difference, so I'm going to note that, all right, the x cubed, that is x all cubed, and 64 is 4 all cubed. And if you don't know those right away, then just use your calculator and try to cube root the value. Sometimes, again, you may have to do common factor first. But you'll get used to them if you practice a bunch. All right. So let's see. We've got a very similar pattern, but notice before it was plus and plus, now it's minus and minus. And before we had a subtraction here, the opposite of the plus we had. Now we have a plus, which is the opposite of the subtraction, and this is always plus. Okay, so there's some patterns to look at in the two. But let's see how we can sub into the formula now. So this would be x minus 4, that's our a minus b, and then a squared, well, that's x squared plus 4 times x plus 4 squared, which is 16. Okay, so that was a video with 3 new formulas for you. Now, what I suggest that you do is begin a formula page. Okay, so each time we use a formula like this, I don't expect you to memorize it. I know you're going to be looking things up. But to help yourself right now, I would say just start making a formula page. I even use a little booklet, something that you can have handy for when you're doing your tests and your homework. Okay, so keep all these formulas handy. Anything to do with exponent rules, factoring formulas, an example of function notation, all of those things. You can begin to make a condensed little notebook of formulas so you're not flipping through all of your homework notes when you're writing a test. Okay, just a suggestion for you. All right, so thanks for watching and see you again in the next video.